In question 1, we'll evaluate the following compositions. In part A, let's find sine inverse of sine of pi over 3. A function and its inverse should cancel each other, so perhaps the answer here is pi over 3. To be careful, to check this, I'm going to draw pi over 3 on a unit circle. So I'll put that over here. Here's my unit circle, and the angle pi over 3 is 60 degrees, so that's like right about there. And what I'll do is figure out, well, first, what's sine of pi over 3? Sine of pi over 3 is equal to the square root of 3 over 2. So sine takes pi over 3 to root 3 over 2. Sine inverse should reverse this. It should take us from root 3 over 2 back to pi over 3. That is true here. So sine inverse of root 3 over 2 undoes this and gives us pi over 3 back. But this is only true if the angle falls between negative pi over 2 and pi over 2. So sine of pi over 3 goes to root 3 over 2, and sine inverse goes backwards from root 3 over 2 to pi over 3, but that's only because pi over 3 falls within this range. For this reason, if you want to compute this part over here, sine inverse of sine of pi over 3 is equal to sine inverse of root 3 over 2, which then takes you back to pi over 3. And that's the answer for part A. So, yeah, these two things do cancel, and it gives us this angle back, no problem. Will the same thing happen in part B, cosine inverse of cosine of 7 pi over 6? Will the answer be 7 pi over 6? I'll take the same approach. I'm going to draw a unit circle, and I'm going to label where 7 pi over 6 is. Well, if I go halfway around the circle, that is pi, or 6 pi over 6, that's the same thing. So if you go pi over 6 more, you're at 7 pi over 6. So here we go. This is 7 pi over 6. So first, what is cosine of 7 pi over 6? I need to use a reference angle. The reference angle is pi over 6. Also, cosine is negative at 7 pi over 6 because it's the x value. For this reason, cosine of 7 pi over 6 is equal to the negative of cosine of pi over 6. They're either equal or they're off by a negative. Because this angle is in the third quadrant where cosine is negative, I have to attach a negative here. Cosine of pi over 6 is equal to root 3 over 2, so this whole thing is negative root 3 over 2. So if we're trying to compute this over here, I'll start with cosine of 7 pi over 6, and here's what we get. We get cosine inverse of negative root 3 over 2. Now, does cosine reverse this and take us from negative root 3 over 2 back to 7 pi over 6? The answer here is actually no. And the reason for this is we can only use angles that go from 0 to pi. So we have to be careful here. We're only allowed to start at an angle of 0 and go to an angle of pi. There must be some angle between 0 and pi where cosine of 7 pi over 6 is equal to cosine of that angle. And I can see it's got to be, well, whatever the point is right up here. It's got to be this angle. The reason is the x value for these 2 points is the same, and the x value is cosine. Well, okay, to get to this point, you would go 1 pi over 6 from here, so 6 pi over 6 to 7 pi over 6. By symmetry, you want to go backwards pi over 6, so from 6 pi over 6 to 5 pi over 6. Long way to go, but we figured it out. The answer to this is going to be 5 pi over 6. The reason is cosine inverse can only give you an answer between 0 and pi, so you're not allowed to use 7 pi over 6. You have to find an angle from here to here where the x values are the same. By the symmetry of the circle, I arrived at 5 pi over 6, and that's the answer. And for part C, what is tangent inverse of tangent of negative 3 pi over 4? Okay, so I think I'll try to use a unit circle again to get the answer for this one. So draw my unit circle, just a very rough sketch. Okay, where is negative 3 pi over 4? Well, if you go backwards, this is negative pi, which is negative 4 pi over 4. So let me write that down here. This is negative 4 pi over 4. So if you go backwards this way one, it'll be negative 3 pi over 4. So here is my angle. Negative 3 pi over 4. Okay. Next step is, well, what does tangent equal at this angle? Tangent is the ratio of sine and cosine, so we can use that to figure it out. All right, so let's see. Tangent of negative 3 pi over 4 is equal to sine of negative 3 pi over 4 divided by cosine of negative 3 pi over 4. Sine and cosine are both negative in this quadrant. So we just have to use a reference angle and note that both of these things will be negative. The reference angle is going to be pi over 4. So tangent of negative 3 pi over 4 is equal to negative sine of the reference angle, which is pi over 4, over negative cosine of the reference angle, pi over 4. Sine and cosine at pi over 4 are equal. They're both root 2 over 2. So this is negative root 2 over 2 divided by negative root 2 over 2. Those are the exact same number, and that's positive 1. So here we go. Tangent inverse of tangent of negative 3 pi over 4 is, well, I'll replace that with a 1, and we have tangent inverse of 1. Okay, last step is, what is tangent inverse of the number 1? The way tangent inverse is defined is, it'll give us an angle between negative pi over 2 and pi over 2. Not inclusive, but from here to here. So we want an angle where tangent is going to be equal to 1. Well, tangent is positive in the first quadrant, so it has to be this angle here. This angle must be pi over 4, and that's the answer. Tangent inverse of 1 is pi over 4. In question 2, we have a right triangle, and we are told that the measure of angle B is 51 degrees, so that is here, 51 degrees. It's a right triangle, so this is a 90-degree angle. And we're also told that the length of side A is 15, so I'll label that as well. To solve this triangle, that means we have to find the missing angle, which is angle A, and the other two sides, B and C. So let's figure those out. To start with, if you want to know the measure of angle A, this thing here, I know that if you add the three angles of the triangle together, they have to sum to 180 degrees. This is true for any triangle. And angle C is 90 degrees. So if you subtract 90 degrees from both sides, you get A plus B is equal to 90 degrees. We know B is 51. I'll plug that in right here. So A plus 51 degrees is equal to 90 degrees. And if we subtract 51 degrees from both sides, we've solved for A. A is equal to 39 degrees. So there we go. We got one thing. We know the measure of angle A. That leaves us with finding the length of side B and the length of side C. We can use some trig functions to help us find the remaining sides. So let me label first that angle B is 39 degrees. If you want to find the length of side B, for example, we can use the trig function tangent. So tangent of this angle is equal to the opposite over the adjacent side. So let me put that definition down here. Tangent of angle, of any angle, but of angle A is equal to the opposite over the adjacent side. Let's plug in what we know to this formula. That is, tangent of 39 degrees is equal to the opposite side is 15, and the adjacent side is B, and we don't know what B is equal to. But that's okay. we can solve this for b. What I'll do is multiply b into this numerator and multiply tangent of 39 into this denominator. We can do this in one step, and when we do, here's what we have. b is equal to 15 divided by tangent of 39 degrees. We don't need the denominator of 1 anymore, but this is the value of b. Now, we're going to round to 2 decimal places, so I'm just going to type this expression into my calculator and round to 2 places as needed. I'm going to make sure my calculator is in degree mode. That's really important. So let me just double check that. It is. So I'm going to type in 15 divided by tangent of 39. And to 2 decimal places, I get 18.52. So b is 18.52, approximately. Approximate length of side b. So again, just be careful here. If you're using this, you want to use a degree mode, not a radian mode in your calculator. The only thing that we don't know is c. A couple ways you could do this. There's several, actually. You could use the Pythagorean theorem, since we know a and b, but we don't know c in a right triangle. But we could also use another trig function, and that's exactly what I'm going to do. I'm going to use the same angle here, angle A, and I know that sine is equal to the opposite over the hypotenuse. So I'll write over here that sine of angle A is the opposite over the hypotenuse, and I'll fill in everything that I know. I know the angle is 39 degrees. I know the opposite side is 15. I just don't know the hypotenuse, which is c. Solving this formula is going to be identical to solving this one. I'm going to multiply the c to this numerator, the sine of 39 to this denominator, and type my answer into a calculator. So I'll put that up here. That c is equal to 15 divided by sine of 39 degrees. Okay, so 15 divided by sine of 39 is, to 2 decimal places, c is equal to 23.84. And I know a, b, and c, both sides and angles, and that means I have solved this triangle. And in question 3, I have 4 trig functions, either sines or cosines, and I want to match them to their appropriate graphs, and then label the period and amplitude. So I think one way to do this would be to, I'll look at the function for the first graph here, and just by looking at the graph, try to determine the period and amplitude. So without having a function, just from the graph, I know the period is equal to 4, because that's one length. So I'm going to say, all right, period here is 4. And the amplitude is 2, because that is the distance away from, the furthest distance away from the x-axis this graph goes. Also, this is definitely a sine function. Sine starts at 0 and ends back at 0. So I want to choose the function, well, first of all, that is sine, and that will match with the period and amplitude. And that's going to be d. 2 will determine the amplitude, and this pi over 2 can determine the period. The formula that we have for determining the period is you take 2 pi and you divide it by the value that's in front of the x, which in this case is pi over 2. So if you simplify this, the pi's cancel. 2 divided by a half is 4. So all that being said, for the very first graph, that's going to be d. For 2, let's see. Well, this is definitely a cosine function because it starts at the highest point. It's not at 0. And it ends back at that highest point again over here. So I'm looking for a cosine function. Again, it looks like the period is equal to 4 and the amplitude is 2. Therefore, this has to be graph C. It's cosine. This 2 determines the amplitude, and this pi over 2, just like over here, will give me a period of 4. So for these last 2 graphs, working backwards, again, this one's definitely a cosine function. Starts away from 0 and ends back here. From looking at the graph, the period is, let's see, looks like it's pi, and the amplitude is 1. So it's a cosine function whose period is pi and amplitude is 1. Well, it has to be this equation here. It's got to be b, but it makes sense. The number in front of the function is 1, and here we have a 2x. So if you try to determine the period this time, it's 2 pi over the number in front of the x, which is 2, and that gives us the period of pi. So same idea over here. This is definitely a sine function because it starts and ends at 0. The period is definitely pi, and the amplitude is 1. That must be this graph here. So it's got to be graph A. And that is it for this problem.